Okay, starting on the first one, you may need to pause these videos to write these down. I'm gonna just get to talking, so you can pause this now and write it down, and then come back to me speaking. Um, so I'm gonna go through and do several of the circle ones, and then several of the trapezoid ones, and then the kite and the rhombus. Okay, so this is our first one. So number 45, it says for a circle with a diameter of 22 decimeters, find the area rounded to the nearest hundredths. Okay, so if you look at your formulas that you wrote down when you went through the vocab, okay, we use area for a circle is pi, is pi r squared, okay, and r stands for radius, okay. So we have, going across here, they didn't give us radius, they gave us diameter, okay. So diameter is the one that goes all the way across, so that would be this one. And this is the one that we need. So we know that radius is half what diameter is, okay? So to find this, they're just splitting it in two, okay? So that's this one right here. So 22 divided by 2 would make this 11. So this is the one that we want to use to do that part. Okay, so now you're just plugging it in. Okay, they told you to use 3.14 because pi goes on forever in your calculator. Okay, some of you actually have the pi button, but if they tell you to use 3.14, I would just use a 3.14. Okay, so I'm just replacing my formula. So pi is 3.14 times radius. So our radius is right here, which is 11. Okay, and I need to square it. So now you just need to remember order of operations. You've got to square the 11 first. Okay, before you do multiplication. So don't go 3.14 times 11 and then square it. That would be wrong. Okay, so order of operations, if you squared 11, you would get 121. Okay, it's 11 times 11. And then you're going to multiply that times 3.14. So in your calculators, 3.14 times 121 is 379.94. I told you to go to the hundredths, so hundredths is the second place value. Okay, so that's our answer for that. Okay, then we're going on to the next one. Is number 48. Okay, so number 48. I'm just going to find it so I can read it. So a circle has an area of 16 pi square centimeters. What is the circumference? So they're not asking for area. Okay, they want us to find what the circumference is. Okay, so when we're doing that, our formula is pi r squared. Okay, and right now they've already, because they tell you what the answer to the area is. Okay, they left pi, so they did not multiply it times pi. But this part is the answer to this. So we need to find out what radius is so that we can plug it into the circumference formula. Okay, so really the 16 pi, again, the pi is this part. We are solving for this part. Okay, so this is really r squared equals 16. And we wanted to solve for r. Okay, so what you're doing to get the r by itself, the opposite of square is to take the square root. Okay, so when I take the square root gets rid of the square. Okay, but what I do to one side, I've got to do to the other side. Okay, so the square root of 16 is going to be 4. Okay, so now we have the r. Okay, then we need to plug it into finding circumference, which was one of the formulas that you wrote. Okay, so on that it's 2 pi r. Okay, well, we just figured out what r is. Okay, so we're going to go 2 times the r, which is 4. And they left it in pi format, because notice it doesn't say pi is equal to 3.14 to use that. So if it doesn't tell you, then you're going to leave it in that format in pi. So all you have to do is multiply those two numbers together. Okay, so 4 times 2 is 8, and then just bring the pi down, because they don't want you to multiply it times 3.14. Okay, and that's your final answer. Okay, so we were finding circumference, and that's the formula for circumference. Okay, one more circle one, similar to this one. Okay, number 49. So again, if you need to pause this to write these down, pause it and then come back to me explaining. Okay, so a circle has an area of 400 pi. It's just like the last one that we did. But this time they want us to know what the diameter is, not what the circumference is. Okay, so to do that, we need to convert to figure out what radius is. Okay, so remember, we have the difference between diameter and we have the difference between radius. Okay, so once we get our answer to find diameter, so when we solve for r, like we did in the last one, you are going to just multiply it times 2 to figure out what the diameter is, because diameter goes across. It's twice whatever the radius is. Okay, so just like the last one, okay, it's pi r squared, okay, and they have 400, and it's pi. Okay, so the pi part is there, okay, that stays the same, so we're just ignoring that part. So really we're solving for the r, just like the last one that we did. So to solve for r, you've got to take the square root of 400 to get the r by itself. Okay, so r is going to be 20 when you put it in your calculator. So 20 times 20 is 400. Okay, so remember that gave me r. So r is this one right here would be 20. They don't want to know that. Okay, they ask for diameter. So I'm taking this answer and I'm going to multiply it times 2. Okay, and that gives me the diameter. Okay, if I wanted radius, then I would have divided by 2, but we're not, we're going backwards, so we're multiplying by 2. Okay, so 20 times 2 would make it 40. And that is your diameter. Okay, so we're done with the circle ones. Okay, now we're going on to another shape. Okay, so I guess I put my papers down here. Okay, so we're going on to number 41. So it says find the area. Okay, so this is an example of a trapezoid, which you should have in your notes. Okay, so trapezoid is A equals 1/2 base 1 plus base 2 times h. Okay, the key thing on this, the bases are always going to be the ones that are parallel to each other. Okay? So parallel would be this one and this one. So when they give you those two numbers, it really doesn't matter which one's which. Okay, it's just the two numbers that are parallel to each other. H is always the one that forms a 90 with a 7. Okay, so H has to be the perpendicular one, and most of the time they just put a dashed line in there showing that they went from the height, which means the tallest part. Okay, and it goes down to the other side and makes a 90 degrees. So this is your height. Okay, so we're just plugging it into our formula and simplifying it, and obviously using order of operations. Okay, so I'm plugging it in. So I have 1/2 parentheses my bases, so 16 and 24. Okay, so I'm going to go 16 plus 24 in parentheses times my height, and we said the height was going to be the one that's on the inside of the dashed line, which is 6. Okay, so order of operations, parentheses first. Okay, so the 1/2 is still there. So 16 plus 24 is going to give you 40. And now all I have is multiplication. Well, multiplication and division if you want to look at those first two. So in multiplication division, you just go from left to right. Okay, so if I find half of 40, that's going to give me 20. And now I just need to multiply times 6. Okay, so 20 times 6 would give me 120. Okay, and because we have inches, it doesn't stay as just inches. When you're finding area, it's squared. So sometimes they might trick you on the multiple choice ones and put this. That would be wrong. Okay, when you're finding area, you will always see that square bar. Okay, so it's 120 inches squared. Okay, so now moving on to number 59. Again, pause this video if you need to write this down. So I'm reading it. An isosceles trapezoid has bases of lengths 7 centimeters and 21 centimeters, and the legs of length 9 centimeters. What is the area of the trapezoid to the nearest tenth? Okay, so in the answer, we just want to go 1 decimal spot. Okay, so I'm going to draw what that would look like. Okay, so trapezoid, this has the opposite sides, one set of opposite sides being parallel. Okay, so 7 up here, 21 here. Okay, and then when it says the side lengths, that's these guys over here. And when it says isosceles, it just means that these two sides are the same. Okay, so when it has 9 here, that means that this one is 9 over here as well. Okay. All right, so in order to do our formula, we actually need to know the height. And remember I said the height is the one that always has that dashed line going through, so it goes to the tallest part more than 90 side. And we don't have one on either side. Okay, so we actually have to solve using our Pythagorean theorem that we learned from last time. Okay, so by doing that, by creating the height, I created, because remember it goes 90 to the side, I created a right triangle. Okay, this is a right triangle. So I need to find out what this is here. Okay, and this one is the same thing, so it really doesn't matter which one you're looking at. Okay, that's a right triangle. Okay, I don't know what this is. But you can get that information based on what is up here. Okay, so from here to here is 7 centimeters. Okay, so that means from here to here, this is also 7 centimeters. Okay, well, if these two triangles are the same, then all I need to do is subtract 7 from 21 to find out what is left over, which would be the total of these two. But when I want to know just what one of them is, then I'm going to divide by 2. Okay? So if I subtract 7 from 21, okay, so 21 minus 7 gives me 14. So that means this and this added together are 14. If I want to know what just one of them are, then I need to divide by 2. Okay? So that means that this is 7 and this is 7, which makes sense, right? Because if this was 7 and this was 7 and this was 7 and I added it together, then that means that total would be 21. Okay, so now I can use this. Okay, so I'm going to ignore my trapezoid and I'm just looking at one of my right triangles. Okay, and I just figured out that the base was 7. Okay, they tell me the hypotenuse. Okay, the hypotenuse is 9. So I'm solving for either the A or the B. Okay, so we're going back to our Pythagorean theorem. So a squared plus b squared equals c squared. So remember, this is the one that is important. So the c needs to be a 9, because that's the side that is always opposite of the right angle. Okay, so I need to square that. A and b really doesn't matter which one's which, so I'm going to assign the 7 the a, okay, squared. But I don't know what the b is, and that's the part we're trying to find, so we can plug it back in to find the area of the trapezoid. Okay, because I need to know what the height of this is, so I can plug in my bases and my height for the area of that trapezoid. Okay, so 7 squared would be 49, and then 9 squared would be 81. So to solve for b squared, we're going to subtract 49 to the other side. Okay, so I have b squared equals 32. Okay, so now to find out what b is, we've got to do the opposite of square, which is to take the square root, right? So I'm going to take the square root gets square root of the square, but I got to do that to the other side. Okay, so this is the part where I made a mistake. If you were to actually plug that in, you would get a decimal that's non-terminating. Okay, so you don't want to do that. Don't plug it in and go to the tenths like what they were saying. Leave it until the last. Okay, so I'm going to show you. This is what not to do. So don't write this. I'm just showing you. Okay, so when I took the square root of 32, I actually got 5.7. Okay, so then I plugged it into my formula where I have 1/2 one of my bases. So the two parallel lines were 7 and 21. Okay, we add those two together and then multiply it times the height, which I just found, which is 5.7. Okay. Well, if you were to add this, 7 and 21 gives you 28. Divide by 2, okay, which would give you 14. If you multiply 14 times that, you end up getting 79.8, which was wrong. It was close, but it's wrong. Okay. That's not what they want. So I got to show you what you should be doing. Okay, so we found out that it's supposed to be the square root of 32. Do not find the decimal until the end. Okay, so what you're going to do is we're writing our formula. Okay, it's 1/2. The bases were 7 and 21, so that part hasn't changed. But we're going to leave this radical format until the end. Okay, so what you're going to do is you're going to go 7 plus 21, which is 28, and divide that by 2, which is 14. Okay. Then you're going to times that by the square root of 32. So you actually need to do that part first. Okay, so you're going to hit the square root of 32 and have that number in your calculator, which is like a decimal, real long decimal. Okay, and then you're going to times it by 14. So you actually need to go backwards. Okay, on this one to get the right answer. So when you do that and times it by 14, you should get 79.2, and that was the correct answer. So like I said, these two are very close to each other. It's just a matter of order of operations. Okay, just so you have all the right answers. Okay, so that one is the correct answer. It was close to 79.8, but it's not correct. Okay, going on. Okay, I need you to write down, this is just to help you so you don't always have to do the a squared, b squared equals c squared. These are called a list of the Pythagorean triples. So these always work out. Some of them you won't, like today. We don't have some of these on here, but a lot of times they will to solve for some of the other triangles. So pause this video, make sure you have these listed out. And this is just, this makes a right triangle. When you square this, add this to get that. These are always right triangles. Okay, so make sure you get those written down. Pause the video if you need to. It'll be part of your notes. Okay, now moving away from trapezoids, now we're going on to kites and rhombuses. We're almost done. Okay, so number 42, it says find the area of a kite ABCD if BD is 24 centimeters, AD is 15 centimeters, and DC is 37 centimeters. And it says the kite is not drawn to scale. Okay, so just basically ignore that. Okay, so we're going to start filling in what we know. Okay, so we have this color BD. Okay, so that's this one right here. So BD is 24. Okay, so that's this segment right there. AD, which is this one right here, is 15. Okay, and then DC, which is this one, is 37. Okay, so something that they did not have in the book, and so I need you to add it to your vocab, is one of the formulas. And the formula for a kite and for the rhombus. Okay, so you want to add this. Okay, so formula for kites. And for rhombus when they give you the diagonals. So the area is the diagonal 1 times diagonal 2 divided by 2. Okay, so when they give you the diagonals, which here in this case we only have one of the diagonals, which is 24, we need to find out what this other diagonal is, which is going to be this one right here. Okay, so we're going to have to solve and use what we know about the area of triangles to figure this out. Okay, so what we're trying to do is we need both of our diagonals to solve this formula. And currently we only have one of the diagonals, so we have to figure out this other diagonal here. So what we're looking at now, okay, so I wrote on here, find the other diagonals, but to do that, we're finding the height of two separate triangles, okay? So what we're looking at when we're missing this is there's a triangle here, okay? And then a separate triangle that's over on this side, okay? And by looking at this, we're finding the height of those triangles. And the same thing here, when I'm looking at this, I'm finding the height of the triangles, okay? So what I'm going to draw is I'm going to take the information that we have here. So on a kite, these guys are the same, so that means that this is also 15, and then this one and this one would be the same, which is 37. So I'm going to take those two triangles and just draw them differently so I can see what it is that I'm looking at, okay? Okay, so the one on the left that has a 15, I'm just going to draw going upright. Okay, so this is 15, this is 15, and then this bottom one was the diagonal that I knew, which was 24. Okay, and what we're solving for is the height of this triangle. Okay, so remember we can split this. okay? And then just take half of our triangle that we have here to solve using our a squared plus b squared equals c squared. So I just want to look at one side of this triangle, okay? I know that this is 15, this is a 90-degree angle, and I took half of the triangle. So if the whole thing was 24, then this part that's right here is just going to be 12, okay? So now I have my C, and then either my A or my B to solve for the missing side, okay? So similar to the last one that we did, so I'm going to go 12 squared, make that 98. I don't know what the height is, okay? That's the other side, but I know C has to be a hypotenuse. Remember, that's the one that's opposite of the right angle, okay? And I need to square it. Okay, so now I've got 144 plus b squared equals 225. Okay, so to solve for b, I would subtract the 144 over to the other side, and that gives me b squared. So when I subtract that, I get 81. Okay, but I don't want b squared, I want b. So to take the square root of that, that would give me b. Okay, so b is 9. Okay, now I need to solve for the other side of the triangle because I just did the left side of the kite. Now I need to do the right side of the kite. So what I meant by that, okay, we solved for this one, right? So I found this part of the diagonal. I only found that part. So now I need to look at this as the same type of triangle I was just doing, but I need to solve for this one so that we can add those two numbers together to get that full diagonal. Okay, so I'm just repeating the same process I did, but now for the other half of that kite. Okay? I don't know why it doesn't let me do that. Maybe. Hold on. Trying to get my board to function for me. Take me to midwinter. There we go. Okay. So now the other side of the triangle, okay, I have, and I'm just flipping it up, right? Okay, so I had 37 and 37, and then again, this was 24. So just like the last one, we want to work with the right triangle, so we need to find height. Height is always formed by the 90-degree angle, okay? So we only want to look at that half of this triangle, okay? So 24 is the whole thing, so I just want that, which is the same as the last one. Okay, so I'm just redrawing this. Okay, so that means that this is 12, okay, and the hypotenuse is 37, okay, and I'm solving for A or B. Okay, so same exact thing as what we just did. So I'm going to have 12 squared plus, I don't know what one of my other sides is, but I know that my hypotenuse is 37 and I need to square it. So 12 squared would be 144. 37 squared, subtract my 144 over to the other side to get my b squared. And my b squared is 1,225. Okay, but I want b, so I would take the square root of that. So b is 35. Okay, so now I have my 9 and I have my 35. Okay, so now I can figure out what the length of that diagonal is. Okay, so going back up here to our drawing, okay, we know the diagonal here is 24, so we'll be able to fill that into our equation over here. But now we just, after doing what we did, figured out the length of this and the length of this that we're putting together. Okay, so the two lengths were 9 and 35. Okay, so you're adding 9 and 35 together. Okay, to get 44. Okay, and again, this is just what we've got here, so I'm just making this a little bit cleaner now. Okay, so the length of that one was 24. Okay, and this one right here was 9 and 35, so add those two together to get the 44. So now we can plug it into our equation. So the area formula is to take one of the diagonals, which is 24, and times it by the other diagonal, which we got 35 plus 9 would be 44, and then divide by 2. Okay, so 24 times 44 gives me 1,056 that we are dividing by 2. Okay, so the area formula is 520. And then I don't remember what the notation was for that one. So 42 was centimeters. Okay, so centimeters squared because we are finding area. Okay, one last one, and this one's an easy one for you. Okay. 52. It says if a rhombus has diagonals with the lengths of 12 and 8. Okay, so they already told us the diagonals. You don't have to find it like we did last one. Okay, so one of those is 12, the other one is 8. Okay, so we already have what we need for the formula. So remember, you're taking the diagonals, diagonal 1 times diagonal 2, and then you're going to divide by 2. Okay, so one of my diagonals is 12, the other one is 8. And then I'm going to divide by 2. So 12 times 8 would be 96, and then divide by 2, so that means the area is 48. Okay, and it's centimeters. Okay, so when we find area, we don't leave it as centimeters, so we're going to put centimeters squared. Okay, so the difference between just the lengths and actually finding area, you need to make sure your notation has a square. Okay, so that is it. Be ready for the test tomorrow on the previous section, and then on Friday you'll be using this to finish out the rest of the notes. Okay, so no homework, just make sure that you've listened to this a couple of times to make sure that you're understanding what you're writing, okay, and that it's legible so you can follow it. Okay, see you soon.